All right, folks, welcome to Unit 2, Mapping and Spatial Representation. In this unit, you will be learning about defining and describing data and information and how it is organized into files for use in a computing and GIS environment, highlighting the difference between primary and secondary data sources, and understanding the importance of metadata and data standards, identifying and evaluating key considerations when searching for data, reviewing the most frequently used measures of distribution, central tendency, and dispersion. We'll also define what a map is and describe reference, thematic, and dynamic maps. And we'll describe and discuss the concepts of map scale, coordinate systems, and map projections, and explain why they are central to maps, mapping, and GIS. We'll also highlight the decision-making process behind maps and underscore the need to be explicit and consistent when mapping and using GIS. In addition, we'll also explore ArcGIS Online Basics, where we'll be spending our labs during this course. So, assignments for the week. You are reading chapters 2 and 3 in your textbook. You also have a quiz, Unit Quiz 2, and you are doing 2 labs out of your lab manual. You are doing labs 1-1 and 1-2. All of that is due on February 2nd, that's Sunday night, at 11:30 p.m. So, a little bit more about what we'll be jumping into this unit. In Chapter 2, data, information, and where to find them, you'll be zooming in on the foundation of any GIS project, data and information. So data refers to raw facts or measurement, while information is what you get when data is processed and interpreted. So turning numbers and observations into insights. We'll look at the difference between primary data, information that you collect yourself, like field measurements, and secondary data, like existing sources such as government repositories. We'll also talk about metadata, essentially data about your data, which tells you who collected it, when it was collected, how accurate it is, and several other things. Proper metadata ensures that the data sets you use can be correctly understood and integrated. Another thing that you'll cover in that chapter is that consistency is key in GIS. So we'll go over common data standards and formats like shapefiles and GeoJSON, which make it easier to share and work with spatial data across different platforms. You'll learn tips for defining your data requirements up front to avoid duplication and save time down the road. We'll then discuss how to find the data you need, whether that's through open data portals, government agencies, or commercial providers. We'll also cover ways to evaluate data sets for quality and relevance, along with practical steps for searching, filtering, and organizing data effectively. And I am really going to harp on organization this unit. Finally, we'll highlight that data management is an ongoing process, from gathering the data to interpreting to updating. By applying solid principles of organization and careful handling of metadata, you will be set up for success in any GIS project. Moving on, you'll also be reading Chapter 3, Map Anatomy. In Chapter 3, we'll be focusing on the anatomy of maps, what they are, the different types, and how we use them in GIS. Maps are basically symbolic representations of places. They show us how different features relate to each other in space. So we'll start by exploring 3 main types of maps. Reference maps display broad geographic features like roads or boundaries. Thematic maps highlight specific data patterns. Think population density or temperature ranges. Dynamic maps, our third type, are interactive, allowing you to pan, zoom, and toggle layers on and off, which is probably the type of map that you all are most familiar with at this point. Next, we'll discuss map scale, which tells you how map distances compare to real-world distances and how small-scale maps cover large areas with less detail, while large-scale maps zoom in on smaller areas with more detail. Coordinate systems like longitude and latitude, and projected systems such as UTM, which you'll understand later, and don't worry about these acronyms now, those will help us pinpoint locations accurately on Earth. Map projections come into play when we flatten Earth's curved surface onto a two-dimensional map. We'll look at several different projection examples, such as the Mercator, the Robinson, or the Lambert conformal conic, each with its own set of compromises in areas like shape, distance, or direction. As it turns out, in mapping, as in life, you can't have it all. We'll also cover how cartographers generalize and symbolize real-world features, turning them into points, lines, or polygons, and why that simplification helps communicate the right information for us. Lastly, we'll see how maps are used in the real world, from visualizing environmental data to planning emergency responses. Throughout it all, the key takeaway here is that good map design helps us communicate spatial information clearly and effectively. So the two takeaways from this unit, if anything, are organize well and consider how design impacts the communication of your map. All right, let's move on to talk a little bit about your labs for this week. So your lab topics this week are all just about exploring ArcGIS Online basics. So you'll start with a map and you'll tour ArcGIS Online in some detail. Some notes that I have for you in this first week of labs is to take your time. This chapter is going to be foundational for future labs. So if you can't make the basic steps a part of your genetical structure for the rest of this course, you're going to have to keep looking back at this lab. It's okay if you have to do that. That's not a problem. But the more you focus this week, the more you take your time and really try and solidify the basic skills of operating in this platform, saving, opening a new map, organizing, the easier it's going to make you, it's going to make it for you moving forward. So a few tips to go along with that. The first is you're going to be asked to make your map public, okay? I don't think that you will have the privileges at your user level to make your map public. So instead, I'm going to ask you to share it with your organization. Okay. Next, when you save maps and layers, use the name and organization conventions from the book. Okay. I have said this before and I'm going to say it again. This is an important step because it's going to keep you organized. And it's also going to make sure that I can find your files so I can grade them and help troubleshoot along the way if you ever have any questions. Next, we're going to talk about organization. The book is going to explain this, but I want you to save everything in your top 20 tutorial content folder. Okay? And I also want you to always save with your initials following the layer and file name. These file names are going to be the exact same file names that you'll save on your images when you upload those to MyHeritage to let me know that you've completed your labs. So it's very important that we have consistency. That's both for you to stay organized and for me to be able to check your work and help you out. Lastly, I want to encourage you to save often. Okay, some of these tutorials are pretty short. It's not a big deal if your computer dies in the middle of them. Some of them are not short, and you will be annoyed if you don't save. So if you see that this is going to be a long lab, flip to the end of it, find out what the file name is going to be, save it, and then jump back and return to where you were in the tutorial. Okay. One last tip for lab 1-2. The directions for touring my groups, I think there might be an error there. Don't worry about it. Just keep on working through. It'll be pretty self-evident to bypass that. Okay, so that's assignments for this week. You've got a reading, you've got a unit quiz, you have a couple labs. Those are all due on Sunday again. So before I sign off, I want to leave you guys with a fun website that hopefully inspires those of you who aren't already as excited about maps as I am, about the possibilities that exist in the world of mapping, both for analysis and communication. So this week, I want to highlight something that has been really valuable for me as a student and a teacher, and that's a website called Gapminder. Gapminder is an interactive website that helps you see our world in a whole new way. It was founded by a guy named Hans Rosling, who is a Swedish physician and academic. He's probably most well known for his TED Talks. But Gapminder, anyway, transforms complex statistics into colorful and easy to read charts and maps that reveal how countries are doing in areas like health, income, education, and a ton of other metrics that you get to pick. By exploring these charts, you can uncover trends over time. You can bust myths that you might have in your mind about the state of the world, and just generally better understand global issues. So it's a fun, engaging tool that allows you to see the real story behind the numbers. I'll post the link for that in the unit description for this week. And as always, I'll be in office hours, 5:30 to 6:30, Tuesdays and Thursdays. I look forward to seeing you there. If you can't make them, please reach out over email. And yeah, hope you guys have a good week.